Welcome back to Sleepy Orbits, late again or early, depending on how the night's been treating you. Either way, come in, get comfortable, because tonight's story starts with something that actually happened to the planet you're lying on the night of December the 27th, 2004, while half the world slept. A wave of energy swept through the solar system and struck the Earth. It compressed our planet's upper atmosphere, scrambled the readings of more than a dozen spacecraft, and flooded detectors that were never meant to point at anything so bright. In 1/5 of 1 second, the thing that caused it released more energy than our sun puts out in 250,000 years. And it wasn't close. The source was a dead star on the far side of the galaxy, roughly 50,000 light-years away. Tonight, we're going to tour the most disturbing events in space, the real ones, the flares and collisions and signals and silences that actually happened, that scientists actually recorded, some of which have never been explained. You've probably met a few of them in headlines written to frighten you, but here's the thing most people don't realize. Every disturbing event in the sky, followed honestly to the end of its story, finishes the same way, farther away than it began, and stranger, and quieter. That's the promise of tonight. We'll walk right up to the most violent things the universe has ever done, one by one, and watch every single one of them turn, in the last light, into something you can sleep beside. One thing before we begin. If you fall asleep partway through, good. That's the point. In the morning, tell me in the comments the last thing you remember hearing. And if you make it to the end, tell me which of tonight's disturbing events stayed with you and what you'd like us to explore next. If these nights help you rest, a like or a subscribe helps this channel more than you'd realize. Now, let's begin. Let's go back to that December night because it deserves to be told properly, and almost nobody knows it happened. Christmas had just ended, and at 2:09 in the afternoon, Universal Time, every gamma-ray detector in the solar system saturated at once. Instruments on satellites orbiting Earth, instruments on spacecraft scattered across the system, all of them, in the same instant, pinned at their maximum readings, blinded, like eyes caught in a flashbulb. The pulse was so intense that it bounced off the moon and was detected again, an echo of gamma rays returning from the lunar surface. It ionized the top of Earth's atmosphere, swelling the layer that radio operators depend on measurably all around the planet. For 1/5 of a second, this event outshone in gamma rays everything else in the sky combined, and it remains, to this day, the brightest burst of energy ever recorded arriving at Earth from beyond our solar system. When astronomers traced the direction, they found the culprit already sitting in their catalogues, a tiny exotic object in the constellation Sagittarius, on the far side of the Milky Way, at a distance of something like 50,000 light-years. Consider what that means for one quiet moment. The flash crossed half the galaxy, spreading and weakening the whole way, thinning according to the merciless arithmetic of distance for 50,000 years. And after all that dilution, it still arrived with enough force to squeeze the atmosphere of our planet. The event itself, up close, defies every comparison I can build for you. If it had happened 10 light years away, it would have scorched our sky. It happened 50,000 light years away, and so instead it became a curiosity in the data, a wonder, a paper in the journals, and a bedtime story for you tonight. So, what kind of object can do that? The answer is the first monster in tonight's collection, and it may be the most extreme thing the universe knows how to build. It's called a magnetar. You'll remember, if you were with us on our black hole night, the ladder of dead stars, and rung 2, the neutron star, a full sun and a half of matter crushed into a sphere the size of a city. A magnetar is a neutron star that came out of its birth wrong, or perhaps too right, spinning fast, churning inside, and in the process winding up the most powerful magnetic field that exists anywhere in nature. The numbers stop meaning anything almost immediately, but let's try. A magnetar's field is around 1,000 trillion times stronger than the Earth's. It is 100 million times stronger than anything humanity has ever produced in a laboratory, even for an instant. A magnetar at the distance of the moon would wipe every credit card, every hard drive, every magnetic stripe on Earth. At 1,000 kilometers, its field would interfere with the very structure of your atoms. This field is so strong that it stresses the star's own body. The crust of a neutron star, remember, is matter compressed to billions of tons per teaspoon, the strongest solid in the universe by absurd margins. The magnetar's field twists against that crust like a wound spring. For years, for decades, loading it with strain the way a fault line loads before an earthquake. And every so often, the crust gives way. The star quakes. On December the 27th, 2004, the magnetar in Sagittarius suffered the largest starquake ever observed. Its crust ruptured, the twisted magnetic field snapped into a new shape, and the released energy left the star as that planet brushing flash, a fifth of a second holding 250,000 years of sunlight. The star itself, 20 kilometers wide, survived. It's still there tonight, still spinning, its field slowly rewinding, a coiled thing sleeping in Sagittarius. Now hold the event up to the light and watch it turn, because this is the move we'll make all night. Everything about the 2004 flare that reads as terrifying is, examined closely, a statement about protection. The flash crossed 50,000 light years and could still tickle our atmosphere, yes, but tickle is the honest word. No one on Earth felt anything. No one was harmed. The effect on your life, if you were alive that December, was 0. And you learned about it tonight, 22 years later, from a bedtime story. The nearest known magnetars to Earth sit thousands of light years away, and the arithmetic of their flares says a giant one would need to be within perhaps a dozen light years to genuinely hurt our atmosphere's chemistry. There is nothing remotely like a magnetar within hundreds of times that distance, And magnetars don't even stay magnetars. That's the gentlest fact of all. The colossal field that powers their tantrums drains them. Within 10,000 years or so, a mere blink, the field decays, the quakes quiet down, and the monster subsides into an ordinary, anonymous neutron star, one more cooling ember among millions. The universe's most violent objects are also among its most temporary. Its rage has a half-life. The dead star in Sagittarius that touched our planet in 2004 will spend a few more thousand years muttering, and then it will go silent forever, and the galaxy will carry it the way it carries everything else harmlessly at distance in the dark. Before we leave the flare of 2004 behind, let's do the thing this channel does and ride it. Become the wave itself for a few minutes, the way we've ridden photons before, because the journey of that flash is 50,000 years of the quietest story ever told about the loudest event. You are born in a tenth of a second, in the snap of a magnetic field above a breaking crust. And in your first instant, you are impossibly bright, a sphere of gamma rays expanding at the speed of light with 250,000 years of sunlight packed into your skin. For the first few seconds, you matter enormously. You wash over the magnetar's own neighborhood, scouring nearby space, outshining the entire galaxy in your particular light. And then immediately the universe begins doing to you what it does to all violence. It spreads you. Every second, the sphere of you grows, and the same energy stretches over its widening surface, thinning by the square of the distance, the oldest law in tonight's story. Within hours, you are light years wide and already harmless to anything that isn't practically touching your birthplace. Within a year, you sweep past stars that register you as a bright flicker in their sky and nothing else. And now the long middle of the journey begins and nothing happens, in the way that only interstellar journeys can manage nothing. You cross the spiral arms, you pass 100 million stars, none of them close, because nothing is ever close. Aboard you, no time passes at all. Light does not experience its own journey, but in the world you're crossing, everything happens. You are 3,000 years out when the pyramids rise on a small blue world you're aimed toward. You are crossing the galaxy's mid-plane, while Rome builds and falls. The last ice age ends. Language is invented, then writing, then radio, and in your final century of flight, the creatures on the target world learn, for the first time, to build instruments that can see you coming. They don't see you coming. Nothing sees gamma rays coming. Light outruns every messenger of itself. And on the 27th of December 2004, 50,000 years old and spread across a wavefront wider than the space between stars, you finally arrive at the little blue planet, diluted by a factor the mathematics writes with 40 zeros, and you brush it. You tickle the top of its atmosphere. You saturate a few of its instruments, echo off its moon, and pass on, out the other side of the solar system, into another 50,000 years of thinning. On the world you touched, no one wakes. A few hundred scientists spend a delighted decade on you, and 22 years later, a quiet voice tells your story to people falling asleep, which is, if you think about it, the most complete defeat a catastrophe has ever suffered. You began as the brightest event in half a galaxy. You ended as a lullaby. Humanity has been watching disturbing events in the sky for far longer than it has understood them. And before we meet tonight's stranger exhibits, it's worth visiting the ones our ancestors saw with their bare eyes, because they prove something comforting at the outset. People have always slept under a sky that occasionally breaks, and it has never once mattered. In the spring of the year 1006, the brightest stellar event in recorded human history appeared in the southern sky. A new star, where no star had been, in the constellation Lupus, the wolf. Astronomers in Egypt, Iraq, China, Japan, and Europe all wrote it down independently, and their descriptions agree in ways that let modern astronomers reconstruct the spectacle precisely. It reached perhaps 100 times the brightness of Venus. An Egyptian scholar recorded that its light on the ground resembled moonlight. You could, by several accounts, read by it at night. It hung there for months, fading slowly, and by the next year, it was gone. What those observers had witnessed without any way of knowing was a white dwarf star, the burnt core of a sun like ours, detonating completely about 7,000 light-years away, an explosion outshining 5 billion suns. The witnesses catalogued it, argued about its astrological meaning, and went back to their lives. Wheat was harvested that summer. Children were born, grew old, and told their grandchildren about the year of the bright star. The explosion of 5 billion suns at 7,000 light-years was an heirloom story. Nothing more. 48 years later, in July of 1054, it happened again, this time in Taurus. Chinese court astronomers recorded a guest star so brilliant it was visible in broad daylight for over 3 weeks and remained in the night sky for nearly 2 years. That one was a giant star's core collapsing, the same species of catastrophe that builds neutron stars and black holes. And this time, we know exactly what it left behind, because we can still watch the wreckage tonight. The debris of the 1054 explosion is the Crab Nebula, 6 light-years of shredded star blown outward at 1,000 kilometers per second, and at its center, still spinning 30 times every second, is the collapsed heart, a pulsar, sweeping the nebula with lighthouse beams like a beacon left at the site of an old fire. Nearly 1,000 years later, the event is still running in slow motion, and it has been promoted from omen to ornament. Amateur astronomers point backyard telescopes at it for pleasure. The most violent thing a star can do has become a tourist attraction, and one more closer and stranger. In the 1840s, sailors and astronomers across the southern hemisphere watched a star in the constellation Carina do something no one had ever seen. Eta Carinae, a system holding one of the heaviest stars known, began to erupt, brightening over months until, for a time, it was the second brightest star in the entire night sky, outshone only by Sirius. It wasn't a supernova. The star survived, barely, coughing out 10 suns' worth of its own body in an event astronomers still call the Great Eruption, an explosion impersonating a death. The gas it shed that decade is now a vast, glowing hourglass wrapped around the star, and Eta Carini itself still simmers tonight, 7,500 light-years away. A star that nearly died in front of our great-great-grandparents and decided not to. 3 sky breaks, witnessed by ordinary people, written down by hand. The lesson of all 3 is the same, and it's the oldest lesson in tonight's collection. The sky performs its catastrophes at a distance so respectful that the audience has never once needed to leave their seats. Honesty now requires the one exhibit in this museum with an actual fingerprint on Earth, because there is exactly one kind of space event that has genuinely reached down and touched human machinery. And it didn't come from deep space at all. It came from the one star close enough to matter, ours. In the last days of August 1859, a British astronomer named Richard Carrington was doing what he did every clear morning, projecting the sun's image onto a screen and sketching its spots, when, before his eyes, 2 beads of white light flared inside a sunspot group, brightened for a few minutes, and faded. He had just become the first human being to witness a solar flare. What he couldn't know was that the sun had hurled a colossal cloud of magnetized plasma directly at the Earth, and it was already on its way. It arrived faster than any such storm before or since, crossing the gap in under 18 hours, and when it struck the Earth's magnetic field, the field rang like a struck bell. What followed was the greatest geomagnetic storm in recorded history. Auroras, normally the property of polar skies, poured toward the equator. The northern lights were seen in Cuba, in Hawaii, over Colombia. Across the American plains, the sky glowed brightly enough that gold miners woke and cooked breakfast at 1 in the morning, believing it was dawn. Birds sang at midnight, and the world's one and only electrical technology, the telegraph, went haywire. The storm drove rogue currents through the wires, operators were jolted at their keys, pylons threw sparks, telegraph paper caught fire in offices, and, most eerily of all, some operators found they could disconnect their batteries entirely and keep transmitting, their lines powered by nothing but the sky. That was the Carrington event, and it remains the benchmark, the one time the cosmos genuinely interfered with the human world, and the honest heart of every headline you've ever seen about killer solar storms. So let's give it the honest treatment, because unlike everything else in tonight's museum, this one is a real consideration. And the calm version is still calm, it's just calm with homework. The sun throws these tantrums regularly at smaller scales. A serious storm struck Quebec's power grid in 1989 and darkened the province for 9 hours, and a Carrington-class cloud crossed Earth's orbit in 2012, missing us by about a week's worth of orbital travel. If a full Carrington arrived today, it would not harm a single human body directly. The atmosphere and magnetic field see to that. You could stand outside through the whole thing and receive nothing but the aurora of your life. Its target would be infrastructure, long power lines, transformers, satellites, aviation routing, the copper and silicon nervous system we've built since 1859, and the fix is engineering, not luck. Grid operators now receive space weather forecasts the way ship captains receive storm warnings, satellites watch the sun around the clock, spare transformers get stockpiled, and a storm that once arrived unannounced in 18 hours would today be tracked from the moment it left the sun, with grids hardened and satellites safed before it hit. It's the museum's most instructive contrast. The distant universe cannot reach us at all, and the one nearby star that can reach us gives us a day's warning, hurts no living thing, and asks of us nothing but competent electricians. Even the sky's genuine touch, when it comes, arrives as maintenance, not doom, and it leaves the most beautiful calling card in nature. The next Carrington, whenever it comes, will be the only disaster in history that most of humanity experiences as the best aurora of their lives. Since we've opened the wing of things that actually touch the earth, we have to walk it to the end, because it contains the museum's most famous local exhibit and the most honest conversation of the night. In the early morning of June the 30th, 1908, over a remote stretch of Siberian forest near the Tunguska River, the sky tore open. Witnesses 50 kilometers away described a column of bluish light nearly as bright as the sun, then a flash and a series of concussions that knocked people off their feet and blew out windows hundreds of kilometers distant. A wave of pressure circled the entire globe twice, registering on instruments in England. And when expeditions finally reached the site, years later, they found something that has fed a century of speculation. 80 million trees flattened across more than 2,000 square kilometers, an area larger than a great city, all laid down in a radial pattern pointing away from a center. And at the center, no crater. Nothing had reached the ground. The answer, assembled over decades, is that a small body from space, a stony asteroid, or a fragment of comet perhaps 50 or 60 meters across, entered the atmosphere at tens of kilometers per second and detonated under the stress, 5 to 10 kilometers up. An airburst releasing hundreds of times the energy of the first atomic bombs. It remains the largest impact event in recorded human history. And here is the fact about it that belongs to tonight's theme, told plainly. It struck one of the emptiest places on the planet, and so, in the largest cosmic impact of the modern era, the confirmed human death toll was somewhere between 0 and a handful. The Earth is mostly ocean, tundra, desert, and forest. Even the bullets that do arrive almost always hit the empty parts of the target, because the empty parts are most of the target. Humanity's cities are specks on a world that is itself a speck. A century later, the sky sent a reminder, and this one was filmed from every angle because it happened over a Russian city in the age of dashboard cameras. On the morning of February the 15th, 2013, a 20-meter asteroid, undetected because it came out of the sun's glare, exploded in the sky near Chelyabinsk with the energy of about 30 Hiroshimas, 30 kilometers up. The flash outshone the sun, and the injuries, about 1,500 people hurt, tell you exactly what a cosmic event looks like when it meets modern life, because essentially every single one was caused not by the asteroid, but by windows. People heard the flash, walked to their windows to look, and the shock wave, arriving minutes behind the light, blew the glass in. Cuts and bruises, one broken collarbone, no deaths. The largest impact over a populated area in a century of records, and the casualty list reads like a bad storm. That's the honest scale of the asteroid hazard in a human lifetime. And now hold it against what happened 9 years later, because this is the exhibit the whole museum has been building toward. In September of 2022, a spacecraft called DART, launched by our species on purpose, flew itself into a small asteroid called Dimorphos, 11 million kilometers from Earth, at 6 kilometers per second, dead center, and changed its orbit, measurably, deliberately by more than half an hour per revolution, triple what was needed to count as success. Understand what that means, because no other exhibit in this museum can say it. Of all the disturbing events in space, in the entire collection, the asteroid impact is the only one that has ever genuinely harmed living things on this planet. It's what ended the dinosaurs, and it is also the only one anywhere in the catalogue that our species has already demonstrated it can prevent. We found the one exhibit with a real bite, and we pulled its teeth on the first try on television. The survey telescopes now map the sky nightly. The catalogue of large nearby asteroids is nearly complete, and no known object of consequence is on course for Earth in the next century. The single legitimate monster in the museum is the one we've already learned to fence. And between those two modern airbursts and the story of the fence, honesty requires the museum's central exhibit, the one dark day this wing is really about. Because 66 million years ago, the sky's one genuine weapon landed a genuine blow, and the Earth remembers it in a layer of clay you can touch. An asteroid roughly 10 kilometers across, a mountain moving at 20 kilometers per second, came down at the edge of what is now the Yucatan Peninsula, and the day it arrived was the worst day in the history of complex life. The impact released billions of times the energy of the atomic bombs, carved a crater nearly 200 kilometers wide, and threw so much vaporized rock into the sky that the debris, falling back around the planet, heated the upper atmosphere into a broiler. Then came the long part, the years of dust and sulfur veiling the sun, the collapse of photosynthesis, the cold. 3/4 of all species on Earth ended, including every dinosaur that couldn't fly, and the layer of iridium-rich clay that settled over the whole world that year is still there, in road cuts and cliff faces on every continent, a thin grey line between one Earth and another. There's no softening the exhibit itself, and I won't try. This happened. It's the one entry in 4.5 billion years of geology where the universe truly reached down, and it should be in the museum, plainly lit. But read the whole plaque, because context is what museums are for. That impact was the largest in the last quarter of 1 billion years, and likely one of only a tiny handful of its scale in the entire history of complex life. Mountains that size cross Earth's orbit perhaps once in 100 million years. The gap between Tunguska, a once-a-millennium event that killed at most a few people in an empty forest, and Chelyabinsk, a once-in-geological-ages event, spans 6 orders of magnitude of rarity, and nothing in between has troubled the human story in 10,000 years of records. And more to the point, read the date on the plaque, then look around at where you're standing. That iridium line, that worst day, is why the museum has mammals in it. The great lizards had ruled for 160 million years, and the small, warm creatures of the undergrowth, our grandmothers many million times removed, inherited the emptied world specifically because the sky cleared it. You would not exist. Nothing resembling you would exist without the exhibit's one confirmed rampage. Which brings the Wings story full circle with a symmetry almost too neat to be believed. The asteroid ended the dinosaurs because the dinosaurs in 160 million years never built a telescope. Their heirs in 1/4% of that time built telescopes, mapped the sky's mountains, found essentially all of the big ones, confirmed none are coming, and then, just to be sure, practiced moving one. The one monster with a real bite made the world that grew the one species that could pull its teeth. The museum's bloodiest exhibit is also, at the end of its long label, its proudest. And while we're being honest about impacts, the museum keeps one more exhibit in this wing, behind glass polished by 4.5 billion years, and you can see it tonight without a telescope, hanging over your street. The moon. Because the most violent event in our solar system's local history, by an enormous margin, is not in any distant catalogue. It happened here. In the solar system's chaotic infancy, when the planets were newly formed and the sky was still crowded with leftovers, the young Earth, by the leading account, was struck by another planet. Not an asteroid, not a mountain of rock, a planet, a Mars-sized world that scientists have named Theia, arriving at tens of thousands of kilometers per hour in the largest collision this neighborhood has ever staged. The impact liquefied the Earth's surface entirely, blasted a fog of vaporized rock into orbit, and destroyed Theia so completely that it survives today only as a chemical signature folded into the Earth's own body. We are, in part, made of the thing that hit us, and the orbiting ring of incandescent debris over the following centuries gathered itself, cooled, and became the moon. That's the leading story of the calmest object in your sky. The soft, silver disk that poets hand to lovers, the lamp of every lullaby ever written, is the debris cloud of an apocalypse, compacted and worn smooth, hanging in the dark like a medal the earth earned for surviving its worst day. And it has spent the 4.5 billion years since paying its debt forward, steadying the Earth's tilt through the ages, raising the tides that may have coaxed life from the shorelines, and giving every restless sleeper in history something gentle to look at. Every exhibit in tonight's museum wants to teach you the same lesson, but none says it as plainly as the moon. Catastrophe, given enough time, becomes scenery. Violence, aged sufficiently, becomes the night light. The universe's disasters don't just fail to reach us. The ones that did reach us in the deepest past are the reason there's an us standing on a stabilized world, breathing supernova oxygen, wearing kilonova gold, sleeping. Tonight, under the polished remains of the worst thing that ever happened here. Now we go bigger, because the supernova, magnificent as it is not the top of the universe's ladder of violence. The top of the ladder has a name that sounds almost bureaucratic, the gamma ray burst, and the story of how we found them is a perfect piece of Cold War absurdity. In the late 1960s, the United States operated satellites called Vela, built for a single paranoid purpose, watching for the gamma-ray flash of secret nuclear tests in space. The satellites saw flashes all right, but they were coming from the wrong direction, not from Earth, not from the moon, from deep space. Brief blasts of gamma rays, seconds long, from random points in the sky, at a rate of about 1 a day. It took decades to pin down what they were because they vanished faster than telescopes could turn, and when the answer finally came in the 1990s, it rearranged our sense of what the universe is capable of. Gamma-ray bursts come from other galaxies, billions of light years away, and for their brief lives they outshine the rest of the universe combined. The leading recipe goes like this. A truly giant star, dozens of suns, reaches the end and collapses into a black hole, and in its final second, as the star's body swirls down the new drain, twin jets of matter and radiation punch outward through the dying star at almost the speed of light, drilling out through its poles. And if one of those jets happens to point at you, you see a beam of focused apocalypse, a searchlight of gamma rays crossing the cosmos. A supernova sprays its violence in all directions. A gamma-ray burst aims it, and one March morning in 2008, one of them aimed at us. And this is my favorite fact in tonight's whole collection. A burst arrived from the constellation Bootes, and for about 30 seconds its visible afterglow was bright enough to see with the naked human eye, magnitude 5.3 at peak. If you had been standing under a dark sky at the right moment and looking at the right spot, you would have seen a faint new star flicker on, hold, and fade. Nothing remarkable, one more dim point among thousands. Here is what you would have been looking at. That point of light was 7.5 billion light years away. Not thousands, not millions, billions, with a B halfway across the observable universe, more than half the age of time itself. For those 30 seconds, it was intrinsically the brightest object any human eye has ever beheld, briefly outshining 10 million galaxies. And it was visible across a distance so great that when its light began traveling, the Earth did not exist. The Sun did not exist. And the entire performance was watchable without equipment by any sleepless person who happened to glance up. That's the gamma ray burst in one image, violence so extreme it renders the width of half the universe into naked eye range. So the reasonable question arrives, the one the scary documentaries lean on. Could one happen near us, and could it point at us? And here the honest numbers are almost embarrassingly reassuring, so let's do them properly. First, gamma ray bursts are vanishingly rare. A given galaxy hosts one perhaps every few 100,000 to few million years. And most of those beam off in random directions, harmless by geometry. For a burst to matter to Earth, it would need to happen within several thousand light years and point its narrow jet directly at us. A coincidence stacked on a coincidence. Second, the ingredients barely exist here. Long bursts prefer a kind of giant star that our region of the galaxy has mostly stopped making. There is one famous candidate, and it earned its scary nickname honestly. 8,000 light-years away sits a doomed pair called the Pinwheel, a huge dying star wrapped in a spiral of dust, and early images suggested we were looking at the system nearly pole-on, straight down the barrel of any future jet. For a few years it was known in headlines as the Death Star, aimed at Earth. Then astronomers did what they do. They measured more carefully, and spectroscopy of the system now indicates its axis is tilted somewhere between 30 and 40 degrees away from us, which, for a jet, a few degrees wide, is the difference between a rifle at your chest and a rifle pointed at a different building down the street. It probably was never aimed at us at all. And even the deep time worry has softened into hypothesis. Some scientists once proposed that a gamma ray burst caused one of Earth's ancient mass extinctions 440 million years ago. And it remains just that, a proposal, unproven. One candidate among many for an event with several mundane suspects. In 4.5 billion years of fossil record, there is not one confirmed scar from the universe's brightest weapon. The searchlights sweep the cosmos every day, and the beam has never found us, because the sky is deep and the beams are narrow, and we are, as ever, a very small target in a very large, dark. The Gamma Ray Burst Wing has one more exhibit added recently, and it deserves its plaque because it holds the all-time record, and it brushed our planet in the same odd way tonight's opening flare did. On the 9th of October, 2022, every gamma ray instrument in operation lit up at once with a burst so intense that astronomers, who normally name these events by their dates, gave this one a nickname within days. The Boat, they called it, letters standing for brightest of all time. And the name has stuck in the literature because that's what it was. The brightest gamma ray burst ever recorded by a factor of 10 over anything in half a century of watching. so bright it blinded the very satellites built to catch such things. It came from a galaxy 2.4 billion light-years away, a giant star collapsing into a black hole with its jet aimed, by pure chance, almost straight down our line of sight. And here's the detail that belongs in tonight's collection. Like the magnetar flare of 2004, the boat measurably disturbed Earth's upper atmosphere. Instruments recorded the ionosphere twitching in response to gamma rays that had traveled for 2.4 billion years, since before complex life existed here, and arrived still strong enough to be felt faintly by the electrified skin of our planet. Astronomers calculate a burst like it points our way perhaps once in 10,000 years, which means the boat was likely the brightest such event over Earth since the invention of agriculture. The whole species was present for a record that stretches back to the first cities, and the total effect on the world was a slight, brief, harmless shiver in a layer of the sky no one can feel, plus several hundred extremely happy astrophysicists. 2.4 billion light-years of mote doing its work. Even the brightest of all time arrives at this address as a whisper with a superlative attached. Here's the twist tonight's collection has been waiting for. The exhibit that turns the whole museum inside out. Because the next disturbing event is the reason you exist, and the reason you own anything made of gold. On the 17th of August, 2017, the gravitational wave detectors we met on our black hole night, the great L-shaped instruments that feel space itself tremble, rang with a signal unlike anything before it. Not the brief, deep chirp of black holes merging. This one sang for 100 seconds, climbing in pitch, the unmistakable signature of two lighter, denser bodies spiraling together. Two neutron stars. The city-sized corpses themselves caught in each other's grip in a galaxy 130 million light-years away. And then, 2 seconds after the waveform peaked, satellites caught a flash of gamma rays from the same patch of sky, and within hours, telescopes on every continent and in orbit swung toward the point and watched something no human had ever seen. A kilonova, the debris of the collision, glowing. Two dead suns had struck each other at 1/3 of the speed of light, and the wreckage, a cloud of neutron-rich matter blasted outward at 1/5 of light speed, was doing something extraordinary as it flew. It was alchemizing. In that expanding cloud, in the hours after the impact, runaway nuclear reactions were forging the heaviest elements in existence, the ones ordinary stars cannot make: silver, platinum, uranium, and gold. The astronomers watching the glow fade from blue to red over the following days were, quite literally, watching gold being created, freshly minted atoms of it, in quantities the papers estimated at dozens of Earth masses at least, some estimates far more. Whole planets' worth of precious metal cast into space in an afternoon. Follow that thread backward and it arrives at your hand. The gold in a wedding ring, the gold in your phone's circuitry, the gold in every vault and every tooth and every icon in every church, essentially all of it, was made this way, in one collision of dead stars or another, somewhere in our galaxy's deep past, billions of years before the sun ignited. The atoms were flung into the interstellar dark, drifted for eons, folded into the cloud that collapsed to form our solar system, sank into the young Earth, and waited. Every piece of gold you have ever touched is shrapnel. It is the debris of an event exactly as violent as the one in tonight's exhibit, worn smooth by billions of years and a jeweler. And this is the truth about cosmic violence that the word disturbing conceals. The universe's catastrophes are also its only foundries. The calcium in your bones was cast in supernovae. The iron in your blood came from the same fires. The oxygen you're breathing right now left a dying star's furnace long before the Earth existed. Astronomy has a saying, worn but true, that we are made of star stuff, and tonight's collection sharpens it. We are made of the disturbing events. Every one of the explosions in this museum is somebody's ancestor, and several of them are yours. And since we're speaking of collisions, let me give you the gentlest exhibit in the whole museum. The one I save for skeptics who think astronomy is all doom. In the heart of the Perseus galaxy cluster, 250 million light-years away, a supermassive black hole is eating, and as it eats, it drives pressure waves out through the hot, thin gas that fills the cluster. Ripples spreading through a medium at regular intervals, that is, by every physical definition, sound. The black hole is producing a note. Astronomers using an X-ray telescope measured the spacing of the ripples and worked out the pitch, and it is, quite precisely, a B flat. A B flat, 57 octaves below middle C, the deepest note ever detected in the universe. 1,000,000 billion times lower than human hearing, one oscillation every 10 million years, and it has been humming, unbroken, for 2 billion years. The loudest instrument in creation playing one note patiently to an audience of galaxies. Nothing in tonight's collection says the universe's true nature better. Even its monsters, even mid-meal, keep time. Now we come to the signals, the part of the museum where the exhibits stop being explosions and start being messages, or things that look like messages, and the hair on the back of the neck rises for a different reason. In 2007, an astronomer named Duncan Lorimer and his student were sifting through years-old archived data from a radio telescope in Australia looking for pulsars, when they found something that made no sense. A single radio spike lasting less than 5 milliseconds, but so bright it had saturated the instrument, and its signature showed it had come from far outside our galaxy. The energy arithmetic was ridiculous. In under 5/1000ths of a second, whatever produced it had released roughly as much energy as the sun does in days. Nothing known could do that, and worse, it never happened again. One spike in old data from nowhere. For years, the Lorimer burst sat in the literature as a kind of embarrassment, possibly an instrumental glitch, and some researchers openly doubted it was celestial at all. Then more of them turned up. Different telescopes, different skies, same signature, millisecond shrieks from other galaxies, each carrying a day's worth of sunlight in a spark. They were named fast radio bursts, and through the 2010s they multiplied into one of the great mysteries of modern astronomy. Some, even more unsettlingly, repeated. One source in a dwarf galaxy 3 billion light-years away has produced hundreds of bursts in patterns no one fully understands. And when a signal from deep space repeats in irregular clusters from a fixed point, even sober scientists permit themselves a very quiet, very controlled version of the obvious thought. The mystery cracked open at least part-way on the 28th of April 2020, and the culprit will make you smile because you've already met him tonight. A fast radio burst went off inside our own galaxy, close enough for its source to be identified beyond doubt, and the source was a magnetar. The same species of over-magnetized dead star that struck our atmosphere in 2004 caught in the act, this time, of producing a radio shriek of exactly the mysterious kind from a comfortable 30,000 light-years away in the little constellation of the Fox. Suddenly, the puzzle had at least one confirmed answer. Some fast radio bursts, perhaps most, are magnetar tantrums, crust quakes and magnetic snaps on dead stars in distant galaxies, their fury compressed into radio spikes that cross the universe. Not every question is settled. The strange repeaters still argue their case, and astronomers still hold the door open a crack for stranger physics. But notice the shape of the story, because it's the shape of half of tonight's museum. A signal appears that nothing known can explain. Imagination honorably runs ahead. And then patience and better instruments drag the answer back into nature, and the answer turns out to be a already catalogued monster doing an already suspected thing very far away. The universe keeps sending us mysteries, and the mysteries keep resolving into weather, extreme weather on dead stars in other galaxies, nothing so far with intent. Which brings us unavoidably to the 72 seconds. On the 15th of August 1977, a radio telescope in Ohio called Big Ear was doing what it did every night, sweeping the sky on autopilot, listening at the frequency of hydrogen. The channel scientists had long guessed any thoughtful civilization might choose, precisely because hydrogen is the one element everyone in the universe has in common. Nobody was listening live. The output went to a computer printout, columns of numbers and letters marking signal strength. A few days later, a volunteer astronomer named Jerry Eamon sat at his kitchen table reviewing the printouts and stopped. There, in the column for one moment of one sweep, was a signal 30 times louder than the background, rising and falling in exactly the smooth curve a fixed cosmic source should trace as the telescope's beam swept across it, at very nearly the hydrogen frequency, and narrow, dial tone, narrow, the kind of narrowness nature was thought not to produce. Eamon circled the 6 characters of code that recorded it, and in the margin in red pen, he wrote one word: wow. The signal lasted the 72 seconds the telescope's fixed sweep allowed, coming from the direction of Sagittarius, and then it was gone, and it has never come back. Big Ear listened for it for years afterward. Bigger telescopes have returned to those coordinates again and again for nearly half a century, with sensitivity Big Ear could only dream of. Silence every time. One loud, clean, 72-second something from the direction of the galactic heart once in 1977. The honest ending to the story is still being written, and it has grown gentler with time. In the last few years, a research team working from Puerto Rico has assembled the most convincing natural explanation yet. Combing through archives, they found faint signals of the same rare flavor, narrow at hydrogen's frequency, coming from cold interstellar clouds of hydrogen gas, and they proposed that the wow signal was such a cloud momentarily amplified into a brief natural laser, a maser flare, possibly triggered when radiation from an energetic event behind it, something like, of all things, a magnetar flare, lit the cloud at exactly the right instant. If they're right, our old friend from Sagittarius or one of its cousins may have authored the most famous alien signal in history, a dead star and a gas cloud collaborating on 72 seconds of perfect impersonation. It isn't proven. The mystery is not formally closed. Jerry Eamon kept his red-inked printout for the rest of his life, gracious and skeptical about every theory, alien and natural alike, and he died in 2025 without the answer. But whichever ending is true, notice what the wow signal was not. It was not a threat. It arrived, was recorded by a machine, harmed nothing, and left. If it was nature, it was one more distant firework in a museum full of them. And if it was ever anything else, then somebody, somewhere toward Sagittarius, once spent 72 seconds saying something into the dark, exactly the way we do. And their message crossed the void and was received and circled in red ink and kept safe in a drawer for 50 years by a man who never stopped wondering. There are worse fates for a message. Sleep on that one gently. From the signals, we pass into the anomaly wing, the dimly lit corridor of the museum, where the exhibits are not events at all, but discrepancies. Numbers that refuse to balance, patterns that shouldn't be there. This is where science keeps the things it cannot yet explain, and the plaques here are honest about it, so tonight will be too. Start with the anomaly that had a happy ending, because it teaches you how to read the others. In the 1980s, navigators tracking the Pioneer 10 and 11 probes, the golden plaque carriers we once met drifting out of the solar system, noticed something wrong with their trajectories. Both spacecraft were slowing down, very slightly more than gravity said they should. The discrepancy was minuscule, a drift that would accumulate to just a few hundred kilometers over an entire year of flight across billions of kilometers, but it would not go away. And it appeared in both spacecraft symmetrically, and for 30 years it resisted every conventional explanation. Papers proposed modifications to the law of gravity itself, dark matter, drag, new physics. The anomaly acquired a name, the Pioneer Anomaly, and a small devoted literature. And then in 2012, after a heroic effort to recover and reanalyze decades of old telemetry from magnetic tapes, the answer arrived, and it was heat. The probe's plutonium power units radiated warmth. The spacecraft bodies radiated that warmth unevenly, slightly more toward the front than the back, and photons, as our light sail night taught us, push. The pioneers were being braked infinitesimally by their own body heat glowing into space. 30 years of speculative physics dissolved into thermodynamics, done carefully. Keep that story in your pocket as we walk deeper into this corridor, because it's the pattern anomalies usually follow. Most of the ghosts, chased long enough, turn out to be the house settling. But not all of them have settled yet, and the Honest Museum shows you those too. Consider the sky's oldest light, the cosmic microwave background, the baby picture we've used twice on these nights as a speedometer and a seed catalogue. It's supposed to be statistically the same in every direction, random mottling, no favorites. Mostly it is to exquisite precision. But it holds a few features that make cosmologists shift in their chairs. There's the cold spot, a blotch in the southern sky, unusually large and unusually cold, sitting where random chance says such a thing has perhaps one chance in a few hundred of existing at all. When astronomers surveyed the galaxies in front of it, they found something suggestive, a giant supervoid, one of the emptiest regions known, sprawled across that exact line of sight in the constellation Eridanus. And passing light does lose a little energy crossing such emptiness in an accelerating universe. A tidy story. Except the arithmetic, done carefully, says the void can account for only a modest fraction of the coldness, perhaps a fifth, and the rest remains unexplained, a cold that is simply there, on the sky, deeper than its causes. And there's a stranger one. When you map the largest scale ripples in that oldest light, a few of them line up with each other, and the alignment points of all directions along the plane of our own solar system. That shouldn't happen. The oldest pattern in existence should know nothing about the orbit of the Earth. The alignment is confirmed. It survived 2 generations of satellites and cosmologists in a rare fit of drama, nicknamed it the Axis of Evil. The boring explanations, some subtle contamination from local dust, some accident of small number statistics, remain the professionals' favorites. The universe's face is a small canvas at those scales, and coincidences do happen, but nobody has nailed it down. And so it sits in the corridor, labeled honestly, real, unexplained, probably mundane, possibly not. And one more stop in this wing, the largest exhibit in the entire museum, the Bootes Void. Around 700 million light-years away, in the direction of that same constellation where the naked eye burst appeared, there is a hole in the universe. A roughly spherical region 330 million light-years across, containing almost nothing. Where a volume that size should hold tens of thousands of galaxies, surveys have found mere dozens, scattered like fireflies in an empty stadium. It's sometimes called the Great Nothing, and when it was discovered in 1981, it genuinely worried cosmologists because the young universe wasn't supposed to be able to grow an emptiness that large in the time available. The worry has since eased. We met the answer on our Great Attractor night. Voids are what the cosmic web does, the empty cells between the filaments, and the Bootes void seems to be several ordinary voids that merged into one giant, the way soap bubbles do. But standing before it, the mind still swims. One astronomer famously remarked that if the Milky Way had sat at the center of the Bootes void, humanity wouldn't have discovered that other galaxies existed until well into the 20th century, because there would have been nothing near enough to see. Every night, sky would have been an empty vault, one galaxy, hours, and darkness in every direction, and astronomy would have been a lonelier science by far. Instead, we grew up in a crowded, glittering filament, wondering nervously about monsters. The void reminds you what the alternative was. Of all the disturbing things the universe could have shown us, the one we were spared is the mirror with nothing in it. The anomaly corridor keeps one small glass case that I've saved for this point in the night, because what's inside is the single most energetic thing ever to actually strike the Earth from deep space, and it was smaller than an atom. On the night of October the 15th, 1991, a detector in the Utah desert called the Fly's Eye, built to watch for the faint flashes cosmic particles make when they slam into the atmosphere, recorded an arrival that physicists at first refused to believe. A single subatomic particle, almost certainly a proton, had struck the sky above Utah, carrying the kinetic energy of a well-thrown baseball. One proton, a baseball's worth of punch. That is tens of millions of times more energy than our most powerful particle accelerator can give a proton, packed into one speck of matter, moving so close to the speed of light that the difference defies decimal places. The physicists on the project, in a rare fit of theological candor, nicknamed it the "Oh my God" particle, and the name, like the boats, stuck. In the decades since, a handful of similar monsters have arrived, including one in 2023, caught over Utah again, and named Amaterasu after the Japanese goddess of the sun. And here is what makes this exhibit belong in the anomaly wing rather than the trophy room. We do not know what makes them. A particle that energetic should be slowed by the universe itself, sapped by collisions with the cosmic background light, which means these things must come from relatively nearby, cosmically speaking, within a few 100 million light-years. But when physicists trace the arrival directions back, there's nothing adequate there. The 2023 monster traced back toward a void, one of the empty cells of the cosmic web, with no obvious engine in sight. Whatever accelerates them, magnetar winds feeding black holes colliding galaxies, something not yet imagined, it is the most powerful accelerator in existence, and it is currently missing from the map. And yet, notice where this most extreme of all impacts sits on tonight's scale of harm. When the oh my god particle hit the atmosphere, it collided with an air molecule 15 kilometers up and burst into a harmless cascade of billions of lesser particles, a shower that swept through the desert night and was noticed by nothing on Earth except one dedicated instrument built precisely to notice it. A baseball's energy delivered by the universe's mightiest unknown engine across intergalactic space, and the sum total of its effect on our world was a single line in a data file and 30 years of delighted argument. Even when the universe genuinely hits us, dead center, with the hardest thing it has, the blow lands like a raindrop. The atmosphere you're breathing under tonight has been catching the universe's fastest bullets for 4 billion years, so gently that it took us until 1991 to notice it was happening at all. And now, because you've been patient, the last room of the anomaly wing, the one with the velvet rope and the sign reading "Thought Experiments Only," because tonight's museum would be incomplete without the most disturbing idea in physics, the one the internet rediscovers every year or two and loses a collective night's sleep over. It's called false vacuum decay, and I'm going to tell it to you straight, and then I'm going to tuck it in because it tucks in beautifully. The idea comes from quantum field theory, and it goes like this. Empty space isn't nothing, it's a medium with properties settled into some energy state, and physicists cannot prove that our vacuum sits in the lowest possible state. It might, the equations allow, be resting in a false floor, a balcony rather than the ground, stable for eons but not forever. And if, anywhere in the universe through quantum chance a tiny region ever tunneled through to the true floor, that region would expand at essentially the speed of light, converting everything it touched to a new physics. New particle masses, new chemistry, no atoms as we know them, a bubble of different reality growing forever, erasing the universe from the inside out with no warning, because nothing outpaces it, and no experience because nothing survives to have one. There it is. The internet's favorite doom told honestly. Some measurements of the Higgs field's properties even hint, if you squint and extrapolate recklessly, that our vacuum might be very slightly on the balcony side of stable. Now watch it tuck in 3 moves, each one firmer than the last. First, the hint is an extrapolation across energies trillions of times beyond anything tested, the kind of extrapolation that has failed every previous time physics has tried it, and modest tweaks to what we don't yet know about physics move the answer comfortably back to stable. Nobody has ever observed anything tunnel anywhere in any survey of a universe that has run uninterrupted for 13.8 billion years, which is itself the strongest data point. The universe has had 10 to the power of 89 chances everywhere, always, and has declined every one. Second, Even taking the idea at maximum seriousness, the calculated timescales for such an event come out at 10 to the power of a few hundred years, numbers so far beyond the black hole era we visited on another night that every star, every black hole, every proton may be long gone before the dice even warm up. And third, the quietest point, the one the philosophers of physics make with a strange smile. An accelerating universe is carved into causal islands, even if a bubble nucleated tonight in some distant galaxy. Cosmic expansion means it could never reach us. Light itself can no longer cross from most of the universe to here, and anything at our address would require the event to happen almost locally, in the thin sliver of cosmos we're still causally married to, shrinking every eon. The most disturbing idea in physics, examined all the way down, is a possibility with no evidence, on a timescale beyond meaning, from which we are mostly quarantined by the geometry of space-time itself, and which, in the strictest sense, cannot be worried about even in principle, because it cannot be predicted, felt, or survived, and therefore belongs to the one category of fear that philosophy has always known what to do with. The fears that change nothing. Epicurus had the line 2,000 years ago about death itself, and it applies without editing. Where it is, we are not. It's the only exhibit in the museum that might not exist, and even its curators sleep fine. So can you. 2 exhibits remain in the main hall, and they belong together, because both are about disappearances, and both carry a personal note for our own solar system, gently deferred. The first is the star that died without a funeral, in a spiral galaxy 22 million light-years away. Astronomers had been keeping an eye on a monster, a red supergiant 25 times the mass of our Sun, exactly the kind of star that ends in a spectacular supernova. In 2009 it flared up, brightening for months as if clearing its throat for the finale. And then, instead of exploding, it simply went out. When the Hubble Space Telescope looked again, years later, the star was gone, not dimmed, not hidden behind dust, checked and rechecked in every wavelength, including the infrared that sees through dust, gone, with only a faint, fading glow where 25 suns worth of star had been. Astronomers believe they know what they witnessed, and it's the quietest violence in tonight's whole collection, a failed supernova. The star's core collapsed into a black hole, but the explosion, the famous last word, fizzled, and the newborn black hole simply swallowed the star around itself from the inside over the course of hours. No blast, no new star in anyone's sky. A light in a galaxy switched off, the way a lamp goes out in a distant window, and where it stood there is now presumably a fresh black hole, born in perfect silence. Surveys suggest this may be the fate of a meaningful fraction of the largest stars, which solves an old accounting problem. Astronomers had noticed there were fewer supernovae than dying giants, and now we know where the missing funerals went. Somewhere in the sky, every so often a star is unscrewed from its socket without a sound. That's genuinely eerie. I'll grant the museum this one. But note the operative word, silence. The most disturbing exit in stellar physics is also the one that couldn't hurt a fly beyond its own doorstep. The universe's scariest trick is subtraction. The second disappearance was smaller and closer to home in its meaning. In May of 2020, a survey telescope caught a strange little flare in our own galaxy, 12,000 light-years away. A star that brightened briefly with an odd, cool, dusty burp, unlike a nova, unlike anything catalogued. When astronomers worked out what they'd seen, published in 2023, it turned out to be a first in the history of observation. The star had eaten a planet. An aging sun, swelling as its fuel ran low, had reached the innermost world of its own system, a gas giant roughly Jupiter's size, and swallowed it whole, the planet spiraling down through the star's atmosphere and dissolving into it over a matter of days, leaving nothing but that little belch of light and dust as a monument to an entire vanished world. Every listener with a decent sense of foreboding knows why this exhibit is here. In 5 billion years or so, our own sun will begin the same swelling, and Mercury, then Venus, will go the way of that distant giant, and the Earth's own fate, whether it is swallowed or merely scorched as the sun's surface rises toward it, is genuinely still debated by the people who model such things. So yes, in the deepest possible future, our world is on the museum's acquisition list. But look honestly at the timescale, because it's the whole point. 5 billion years. The Earth is 4.5 billion years old now. The span between you and the sun's appetite is longer than the entire history of this planet. Every ocean, every mountain range, every species that has ever lived, all of it run again from the start, and then some. Complex life has existed here for barely 500 million years, a tenth of the buffer. Nothing you love, nothing your descendants' descendants could conceivably love on any time scale where the word descendant retains meaning, lives anywhere near the far end of that clock. The planet-eating star is a genuine preview of our address in deep time. And deep time, as every night on this channel eventually teaches, is the softest place anything can be stored. One small case in this hall of aftermaths deserves its own light, because it holds the museum's best-kept secret about what survives catastrophe, and almost no one knows it. Quick history question. Where were the first planets outside our solar system discovered? Around a star like the Sun? No. The first exoplanets ever confirmed in 1992, years before any were found around normal stars, were discovered orbiting a pulsar, a dead star, the spinning lighthouse corpse of a supernova, 2,000 light-years away in Virgo. Astronomers timing its metronome pulses found tiny rhythmic hiccups and worked out that the hiccups were the gravitational tugging of planets. At least 3 of them, roughly Earth-sized, circling the dead star in tidy orbits. Sit with the strangeness of that, the very first worlds humanity ever found beyond our sun orbit a corpse. They circle the collapsed heart of a star that exploded, bathed in its radiation beams, either survivors of the detonation that should have vaporized them, or, more likely, new worlds condensed afterward from the debris disk of the explosion itself. Planets literally built from supernova wreckage. Second-generation worlds assembled on the site of the disaster. Nobody expects life there. The neighborhood is all radiation and ruin. But as a statement about the universe's habits, the pulsar planets are the museum's quiet thesis, framed and hung. Even at ground zero of the worst thing a star can do, the debris starts orbiting again. Given only wreckage and time, gravity starts building worlds again, immediately, out of whatever's left. The universe cannot help itself. It makes planets in blast craters. Every catastrophe in tonight's collection, run forward far enough, ends in something circling something, calmly, in the dark, which is, after all, exactly how our own story started too. One more hall before the thought experiment room, and this one moves. Most of tonight's exhibits hold still and detonate. These ones run. Scattered through the galaxy's halo, astronomers keep finding stars moving far, far too fast, not drifting with the great carousel like everything we met on our great attractor night, but tearing across it at speeds that will carry them out of the Milky Way entirely, forever. They're called hypervelocity stars, and the record holders defy belief. In 2019, astronomers clocked a star catalogued in the southern sky doing 1,700 kilometers per second, 6 million kilometers per hour. The fastest star of its kind ever measured, on a trajectory pointing unmistakably out of the galaxy into intergalactic space, with no force in existence able to call it back. And when they traced its path backward, the trail led exactly where theory said it should, the galactic center. The star had been thrown. 5 million years ago, it seems, that star was one half of a binary pair that wandered too close to Sagittarius. A star, the 4 million sun monster at the heart of the Milky Way. And the encounter did what such encounters do. The black hole kept one star, binding it into a screaming close orbit, and flung its partner away with the full force of the exchange, a gravitational slingshot at 1/3 of 1% of light speed. The ejected star has been falling up and out ever since, through the disk, through the halo, bound for the darkness between galaxies, where it will drift for eternity, a sun without a sky, its planets, if it kept them, orbiting a star whose night holds no other stars at all, only the faint smudges of distant galaxies. There are dozens of these exiles catalogued now, and statistically the center must have thrown thousands over the galaxy's life. Somewhere out there tonight, beyond the Milky Way's edge, whole solar systems are sailing into the intergalactic dark, evicted by the monster downtown, and it's hard to imagine a lonelier fate, or, notice, a more harmless one. The most violent gravitational engine in the galaxy, the supermassive black hole itself, at its very worst, does not devour the stars that cross it. Mostly, it redistributes them. Even the monster's temper resolves into real estate. and no exile has ever passed anywhere near us because the throws are as rare as everything else in tonight's museum. 1 star per century or so, fired from a downtown 26,000 light years away, into a sky that is, as we have established all night, almost entirely made of mist. The moving exhibits have one more hall, and it holds the largest collisions that exist, because stars are not the biggest things that can hit each other. Galaxies are. Across the deep sky, telescopes have photographed hundreds of galactic collisions in every stage, spirals caught mid-embrace, trailing 100,000 light-year streamers of scattered stars, pairs distorted into shapes with names like the mice and the antennae and the tadpole. Entire star cities merging over spans of hundreds of millions of years. In one famous system, 2 great clusters of galaxies have punched clean through each other at millions of kilometers per hour. An event so violent it literally stripped the gas from the galaxies and left it glowing between them, separated from its stars. These are the heavyweight bouts of the cosmos, the largest events by sheer mass involved in tonight's entire museum. And you have skin in this game, because, as we've discussed on another of our nights together, the next such photograph could be of us. Andromeda, our great neighbor, 2.5 million light years out, is inbound, and in 4 or 5 billion years, the Milky Way and Andromeda will do exactly what the mice and the antennae are doing now. So the museum owes you the honest answer to the obvious question: what actually happens to the stars when galaxies collide? And the answer is the single most beautiful statistic in astronomy. Nothing. They miss. Essentially, all of them. Essentially, always. When 2 galaxies of hundreds of billions of stars each pass through one another, the number of actual star-on-star collisions expected is approximately 0, not few, 0. Because as our black hole night taught us, a galaxy is almost entirely empty space. If the sun were a grain of sand, the nearest star would be another grain several kilometers away, and a galactic collision is 2 clouds of such grains kilometers apart from each other, drifting through one another like 2 flocks of birds crossing in the sky. The galaxies as shapes are transformed, their spiral arms unwound, their gas clouds compressed into glorious firestorms of new starbirth, the merged whole settling into a single great elliptical over an eon. But the stars themselves, and their planets, and anyone on their planets, sail through the grandest collision in nature untouched, their nights slowly filling with new stars, their skies rearranged as gently as furniture over 100 million years. When the largest event in tonight's museum finally happens to us, personally, to our actual galaxy, the odds are overwhelming that nothing whatsoever will collide with anything, and the sky will simply, across ages, no one will be awake long enough to notice, become more beautiful. Even the biggest crash in the catalogue is, at the scale of anyone living inside it, a slow change of scenery. And now the finale of the collection, the exhibit that came to us in our own lifetime, complete with worldwide headlines, and it belongs to a star every one of you has seen. Betelgeuse, the red shoulder of Orion, the warm orange beacon of the winter sky, one of the largest stars visible to the naked eye, and one of the most beloved, and a star we already know is in its final act. In October of 2019, Betelgeuse began to dim. Stars vary, and Betelgeuse, more than most, it breathes in slow cycles that observers have tracked for centuries. But this was different. Week after week it faded, sliding down past every low point in its recorded history, and by February of 2020, it had lost nearly 2/3 of its usual brightness, so much that the change was obvious to anyone who looked up. Orion, the most recognizable constellation in the sky, visibly missing part of itself. And because everyone knows what Betelgeuse is, a supergiant near the end of its fuel, the same species of star as the 1054 guest star, the internet did what the internet does. The great dimming became a countdown. Was the shoulder of Orion about to blow? For a few remarkable months, ordinary people walked outside, found Orion, and checked night after night on the health of a dying star 600 or so light years away, and half hoped, let's be honest, to see the sky break in their lifetime, the way it broke for the astronomers of 1054. The answer arrived through patient telescopes over the following year, and it was, of course, gentler than the headlines. Betelgeuse had not been dying any faster than usual. It had sneezed. The star had belched out a great bubble of its own surface material, and as that gas drifted outward and cooled, it condensed into a cloud of dust directly between the star's southern face and the Earth, a veil of soot dimming the lamp behind it, while a cool patch on the star's surface deepened the effect. By the spring of 2020, the veil was drifting clear, and Betelgeuse climbed back to its usual brightness, where you can check on it tonight if it's winter where you are, glowing over your roof entirely itself. The great dimming turned out to be the nearest miss in tonight's museum, not because danger passed close, but because expectation did. And the expectation deserves its honest answer, so let's give it. Betelgeuse will explode. Sometime in the next 100,000 years, likely sooner rather than later. On that clock, the shoulder of Orion will collapse and detonate, and Earth will get the greatest sky show since the invention of eyes. For weeks, a point in Orion will shine with the light of a full moon, visible in daylight, casting shadows at midnight, before fading over months into a glowing nebula that telescopes will study for 10,000 years. And at 600 light years, safely 6 times farther than the danger line for a supernova. That is all it will be. A show. No harm, no scorching, no extinction, just the most beautiful thing anyone alive at the time will ever see, arriving with 6 centuries of light speed notice. There are people, possibly alive tonight, more likely far downstream of us, who will spend evenings on their roofs beneath a second moon in Orion, and they will not be afraid. because 1,000 videos like this one will have taught the species by then what it took our ancestors 10 centuries to learn about guest stars. The sky breaks beautifully at distance, on schedule, and the audience is always safe. We're near the end now, so let's do what we did on our Great Attractor night and hang tonight's entire collection in your actual sky, because every exhibit has an address up there, and there's a particular peace in knowing where the monsters sleep. Come outside in imagination and look up, face towards Sagittarius, the teapot of southern summer skies, the direction of the galaxy's crowded heart. Behind those star clouds 50,000 light-years down sleeps the magnetar that touched us in 2004, rewinding slowly and in the same direction, nearer, the coordinates where a 72-second signal said its only word in 1977 into a telescope in Ohio. The galactic center itself hides there too, the thrower of exiled stars wrapped in its own dust. Swing to Taurus, the bull riding high on winter evenings, and find the spot near its horn where the guest star of 1054 blazed in daylight, where the crab and its lighthouse spin tonight, still broadcasting. Just below, Orion and the orange shoulder that made the whole world look up in 2019, restored, patient, keeping its 100,000-year appointment. In the little constellation of the Fox along the summer Milky Way, the magnetar that solved the fast radio bursts in 2020 mutters at its comfortable 30,000 light-years. High in spring skies, the empty stadium of the Bootes void yawns behind the herdsman's stars, 700 million light-years deep, and near it, unmarked, the patch where a point of light from half the universe away was briefly visible to anyone's bare eyes one March morning. In Carina, for the southern half of the world, the survivor of the 1840s eruption simmers inside its glowing hourglass. In Eridanus, the river, the sky's cold spot spreads its unexplained chill across the oldest light. And everywhere in every direction, unmarked and unfindable, the quiet ones drift. The failed supernovae, the wandering black holes, the exiled suns, the 100 million sleepers of every kind, sharing the dark between the stars you can name. That's the true map of the most disturbing events in space. Not a minefield, a museum, unlit after hours, its exhibits all in their places, tens, thousands, millions, billions of light years down their respective corridors, and the whole gallery wheeling slowly over your roof once a night, silent as any other ceiling. People pay for guided tours of castles and battlefields, places where terrible things happened long ago, safely fenced by time. Every clear night, for free, the sky offers the same tour, fenced by distance instead, the grandest collection of catastrophes in existence, all of them long ago or far away or both, arranged overhead in perfect quiet. You've walked it end to end tonight. There was never anything in it that could follow you home. Before we close the museum for the night, step back with me into the main hall and take in the whole collection at once, because there's a final exhibit that isn't any single event. It's the rate, the sheer, ongoing, ordinary frequency of cosmic violence, and it is the most disturbing fact of the night and the most comforting in the same breath. Here is the universe's actual schedule. Somewhere in the observable universe, a star explodes as a supernova roughly every single second, several a heartbeat, around the clock, without pause, since before the Earth existed. Gamma-ray bursts arrive at our detectors about once a day, each one the death shout of a giant star in some galaxy far away. The gravitational wave observatories, in their observing runs, now catch black holes colliding somewhere in the deep universe multiple times a week. Fast radio bursts flash across the sky in their thousands per day, most unrecorded, sparks from magnetars in galaxies we'll never name. At this very moment, as you lie still beneath a quiet ceiling, the universe is detonating, colliding, collapsing, and screaming in every direction at a rate no bookkeeping could follow, and it has maintained this pace for 13 billion years. The storm never stops. The storm has never once stopped, and you have never noticed. Not you, not your ancestors, not the dinosaurs, not the first cell. In the entire 4.5 billion year archive of this planet, the geological record, the fossil record, the ice cores, the tree rings, there is not one confirmed entry that reads, "On this date, something in deep space hurt the Earth." Not one, in a universe exploding every second. That is not luck. And tonight, at the end of this long tour, you have every tool needed to see why. It's the moat. It's the same three guardians we keep meeting on every journey this channel takes. Distance, first and mightiest. The fortress we mapped on our way to Alpha Centauri. The emptiness so deep that even light needs years to cross between neighbors, and the violence arrives diluted to weather or to a bedtime story. Expansion, second the widening river from our great attractor night, quietly adding space between us and every distant catastrophe faster than most catastrophes can spread. And rarity, third, the statistics from our black hole hunt, the simple thinness of monsters, 1 per 1,000 stars, 1 per galaxy per age, beams a few degrees wide in a sky of 40,000 square degrees. Stack the three, and the arithmetic of harm collapses into absurdity. The universe fires a quadrillion shots a year, and the shooting range is so vast and the targets so small that the range has never recorded a casualty on our world. The most disturbing events in space, all of them, tonight's entire museum, share one biography: born in violence, traveled far, arrived as light, filed as knowledge. That's the complete life cycle of a cosmic catastrophe, as experienced from Earth, every time it has ever happened. Now, as we finally come to the end of tonight's tour, let's walk back through the museum one last time past every exhibit and watch each one do the thing I promised at the door, ending farther away than it began. The magnetar flare of 2004, which crossed half a galaxy to brush our atmosphere, ends 50,000 light-years away on a dead star already spending its rage, destined for silence within a few thousand years. The guest stars of 1006 and 1054 end as heirloom stories and a tourist attraction, a nebula in Taurus with a lighthouse at its heart. The naked eye burst of 2008 ends 7.5 billion light-years away, farther than the age of the Earth. The colliding neutron stars end as the gold on your finger. The fast radio bursts end as weather on dead stars in other galaxies. The WOW signal ends in a draw in Ohio, circled in red, either a gas clouds accident or the loneliest hello ever recorded, and harmless either way. The anomalies end as they always do, mostly as the house settling, a few still whispering in the corridor, labeled honestly, hurting no one. The vanished star ends as the quietest black hole ever born. The swallowed planet ends 5 billion years from our doorstep. And Betelgeuse ends where it began, glowing over your roof tonight, keeping its appointment for another age's audience. Every door in the museum opens outward, every exhibit followed to its final line retreats, and maybe that's the real reason a channel about sleep keeps returning to the scariest things in the sky, and why you keep coming back to hear them. Fear of the dark is the oldest fear there is, and it was never really about the dark. It was about not knowing what the dark contains. Tonight, you know what it contains. It contains magnetars, 50,000 light-years away, rewinding their springs. It contains gold foundries and failed funerals, voids like held breaths, notes played in B-flat for 2 billion-year audiences, and signals that say, wow, once and never again. It contains, in every direction, at every hour, the grandest violence that has ever existed, all of it padlocked behind distance, diluted by expansion, and rationed by rarity, arriving at your window as nothing more than points of light, so gentle that looking at them makes people sleepy. The universe did not child-proof itself for us. It simply built at a scale where its own fury cannot travel well, and we live in the calm that scale guarantees, the deepest, oldest, most thoroughly tested calm there is. 4.5 billion years without a scratch, in the middle of the storm. There is no safer address than this one in the entire catalogue of addresses. Thank you for joining me tonight in the Museum of the Universe's most disturbing events, from the flare that touched the Earth to the star that vanished without a sound. If this tour changed what the dark feels like, even a little, a like or a subscribe genuinely helps these quiet nights continue, and it's always good to have you here. And the next time a headline reaches you, breathless, about a Death Star aimed at Earth, or a signal from deep space, or a hole in the universe, you'll know the museum it belongs to, and the biography it will follow. Born in violence, travelled far, arrived as light, filed as knowledge. Somewhere above your ceiling right now, a star is exploding. It is so far away that its light will spend the whole future of our species in transit, and when it finally arrives, it will be one faint new point in somebody's night, noted, catalogued, and slept through. The storm rages on, out where it has always raged, and here, at the bottom of our quiet ocean of air, on the far shore of every distance, it's just another night. The house is holding, it has always held. Sleep well tonight, safe in the eye of everything. Good night.